Hi there! Welcome to the first episode of the new series Back to Basics, where we will explore everything electronic, from the simple components to the more complex ones, and where we will learn how to create our own circuits and make sure they are safely working. Darn, what just happened? Look at those remains of that perfectly functional electrolytic capacitor. What happened to it? Ouch, that was potentially very dangerous. Well, it looks like that it is probably better to have a small talk about safety before anything else, don't you think? Let's get to it. Well, let's say it once and for all. Electricity is dangerous. Whenever we work on a circuit, even if powered with batteries, we always need to be careful and pay attention on what we do. Even a simple component like this one can become a true hazard if not handled properly. We always need to pay attention to safety. We could cause an explosion, we could start a fire, we can get burned, we can even get some shrapnel in our eyes if we are not careful. In the end, we need to work safely for a number of reasons. To protect our environment where we work, to protect the devices on which we work, to protect ourselves, and to protect electronic components we are using. Let's dig a little deeper into these points. Before entering in the details of this video, I would like to announce the creation of a new project sponsored by thousands of YouTubers, teamwater. teamwater is a creator-led crowdfunding campaign to change millions of lives around the world through access to clean water. Led by Mr. Beast and Mark Rober, and powered by the biggest team of content creators on the internet, we are raising $40 million to provide millions of people with life-changing access to clean water for decades. And to make sure of the success of the initiative, we are partnering with WaterAid, one of the most trusted water organizations in the world. Founded by engineers, they have a 4-star Charity Navigator rating and the Platinum Seal of Transparency from GuideStar. They've been working at this for 40+ years, with operations in over 30 countries. They don't do quick fixes. They work alongside communities to build long-term sustainable systems with local partners that actually deliver. teamwater and WaterAid will use different technologies depending on what is most appropriate for each community context, climate, and needs. In different places, this might mean a system to draw, collect and clean water, or to distribute water, or to maintain and monitor water supply services. teamwater will work across 5 continents to deliver clear water to communities. From the deserts of Colombia to the mangrove forests of Bangladesh, projects will range from piped connections to homes, gravity-fed water systems on mountainsides, solar-powered wells, desalination systems, rainwater harvesting, and more. The work will be carried out in partnership with local communities, with governments, partners, and a whole host of people critical to delivering a sustainable supply of clean water. Please visit the teamwater website and participate to this big effort to help people all around the world. Link is available in the video summary. And now, back to our subject. Whenever we need to work on an electronic device, it is always better to power it down, whether it uses batteries or the grid power. Always disconnect power before working on a circuit, and if you are not sure whether a circuit is powered or not, just use a multimeter and check it out. The only case where you can work on a powered-up circuit is when you have to test internal functionalities to verify whether it works fine or not. And even then, you should take your precautions to avoid causing short-circuit or touching parts where dangerous voltages are present. Make also sure that you have a good ventilation in your workplace, especially when soldering or dealing with chemicals to make your own PCBs. When the ventilation is limited, make sure you have around you some sort of good air filtering system, like this one to absorb the soldering smokes, or this one to keep the whole room odorless and with clean air. To avoid unpredictable and useless hazards, always keep your workbench clean from clutter. Only put on it what you really need, and try to be well organized. And remember, food and drinks are not among the necessary items on your workbench. Besides the risks of spilling liquids on electronic circuits, never touch food after handling electronic circuits, especially if soldering is done with a tin lead compound. Keep food away and wash your hands immediately once you leave your lab area, even if it's done for only a few minutes. Finally, just for those unpredictable moments, always keep around a small fire extinguisher like this one, as well as a first aid kit and a list of phone numbers to call in case of an emergency. Although workplace safety is important, it is also important to not underestimate personal safety. Especially when working in certain conditions, it is important to wear personal protective equipment or PPE. When the conditions suggest that, it is appropriate to wear safety goggles or glasses to protect your own eyes from sprays of melted solder, from flying wire clippings or chemical splashes, for example while etching a PCB. Insulated gloves become useful when working with high voltages, like the voltage coming from a power outlet. And it is also important to always wear shoes that have an insulating sole, so you are not electrically connected to ground when handling such high voltages. And even if you are not dealing with high voltages, it could still be useful to prevent, for example, sending high impedance signals to ground when touching a circuit under test, or something similar. Sitting on a wooden stool also helps in staying insulated from ground. But obviously there are circumstances where you actually want to be connected to ground, although never directly, but through a relatively high resistance, for example when working on components sensitive to electrostatic charges. We'll talk more about this later. Finally, for your own safety, it is also useful to avoid certain kind of clothes that could be too loose and could snag around anything on your workbench or worse, conduct electricity. And especially for that, absolutely do not wear any piece of jewelry that can touch anything that has an applied voltage and can cause possibly a short circuit or worse, close the circuit through your body. Let's now talk a little bit about components safety. And, besides the usual talks about burning components with the iron solder, or break their leads, or similar other stuff, I would like to talk about a subject that is often underrated: electrostatic discharge protection, or ESD protection. I'm sure that you have probably experienced static electricity several times in your life, for example, when touching a doorknob right after walking over a thick carpet in an environment with low humidity. Did you ever experience a painful shock while doing that? Or sometimes just touching another person in the same conditions, or maybe coming down from a car and getting shocked while touching the metal of the door once your feet are on the ground. All of them are forms of ESD. ESD is nothing other than the sudden flow of charges between two objects that build up opposing charges and found themselves at two different electric potentials. When such objects come into contact, or maybe just when they are close enough to each other, the charges start moving from one object to the other to reach an equilibrium, and that creates a sudden and brief current. The problem with ESD is that while it causes just some discomfort to us, it can cause catastrophic effects to certain electronic components. And the worst thing is that we feel such discharges only if the voltages are very high, but voltages of just hundreds of volts or a few thousands of volts are totally unobservable to us, but they can still cause a lot of damage to electronic components, especially those based on MOS technology. We could be charged enough to break a component as soon as we touch it, but not enough to feel the effect of the discharge. In such a case, we would move on using the component, and then the whole circuit does not work, or maybe it works erratically, depending on the amount of damage on the component. Integrated circuits are the most affected because the discharge can break a part of them, but the remainder works perfectly, and this may cause erratic behaviors. And that's why understanding and preventing ESD is so crucial when handling electronic components. So, how can we avoid such problems? The trick is to make sure that everything on your workbench is charged to the same potential, and it is even better if that potential is the one of ground. Should you then connect yourself to ground with a wire to avoid ESD? No, and for two reasons. First, if we connect ourselves to ground, we violate one of the previous rules on our own safety. Second, if a component is electrically charged and we touch it while connected to ground, we cause right there an ESD event that could destroy the component. So then, what do? We use high-value resistors. High enough not to connect us directly to ground, but small enough to allow the extra charges that may accumulate somewhere to slowly discharge toward ground without causing any damage. And we do the same with the workbench surface. But how? We are talking about surfaces here, the one of the workbench and the one of our own body. How do we connect a resistor to a surface? We don't. Instead, we make the whole surface itself a resistor, and we connect a corner of it to ground, leaving everything else, the other end, ready to discharge any voltage that may come close to it. This is done with wrist straps that we can wear, and it is done with ESD mats, which we lay on top of the workbench surface when we need to work on something that needs ESD protection. This is a typical wrist strap. You strap it around one of your wrists, tight enough that it doesn't move, but loose enough that won't cause you discomfort when you wear it for a long period of times. The wrist strap ends with a wire that can easily be connected to ground. Wrist straps like this have also an internal resistor, usually 1 meg, to make sure we are not directly connected to ground for our safeguard and for the safeguard of the sensitive components. Similarly, these kind of mats can be laid down on the workbench and their wire can be connected to ground, making sure that there won't be any accumulation of charges on the workbench. The ESD mats are made of material that offers a certain amount of resistivity, so that the ESD can happen without causing dangerous currents. But it's not all. Don't think that using a wrist strap and an ESD mat is enough for protecting sensitive components. You also need to store them in a safe place, a place where they cannot be reached by electrostatic charges. The concept is the same. You wrap these components in a resistive material that prevents charges to accumulate on itself, and that prevents those charges that still contaminate it to reach the wrapped component. Welcome to the anti-static bags and containers and to the anti-static foam, both made of plastic mixed usually with graphite, which guarantees a certain resistivity, not too low, not too high. Another important aspect of lab safety is related to the correct handling of the instruments we all use. And the first one I would like to mention is the soldering iron, which we all use, for example, to connect the components to a PCB or to each other. Whenever the soldering iron is on but not being used, make sure you put it on its stand. These stands are usually made of metal, or at least the part that is in touch with the soldering iron is made of metal, capable to resist the temperature of the iron itself. Putting the soldering iron directly on the workbench is not a safe thing to do. It can inadvertently touch something and melt it or burn it. It can fall on the floor, it can land on your lap burning you, and so always keep the soldering iron on the stand when not in use. Another important thing is to keep the tip of the soldering iron perfectly clean. It is clean when it looks like this, like it was covered with a thin layer of shining solder. And in fact, it should be. The solder covering the tip allows it to better transfer its heat to the components and thus have less chances of making bad soldering points. Whenever the tip gets dirty, it should be cleaned thoroughly. Never try to clean it with abrasive objects, like a file or some paper. If you do that, you may risk of ruining the underlying protection of the tip, which will then not be able to work well anymore. To clean the tip, I usually use some rosin paste like this. I heat the soldering iron and I submerge the tip into the paste for a few seconds. Then I remove it from the hot bath and I clean it with a cotton rag. Yes, cotton. Please do not use rags made of synthetic material, because that could melt onto the hot tip and ruin it. Once done that, if there is not enough solder left on the tip, just melt some on the tip and then clean it again with a rag, and keep doing that until it starts shining. Even while you solder, you should clean the tip every now and then. To do that, you can just scrape the excess solder using one of these cleaning sponges made of copper wire. Alternatively, you can use a real sponge kept humid and not totally wet to brush the tip clean. Between the two, the one I prefer is the copper wire sponge, as the actual sponge tends to lower the tip temperature for a few seconds. And of course, while you solder, try to avoid breathing the smoke. If you can, use a fume extractor like this one I made by myself. Otherwise, try to at least ventilate the room or use an air filtering system set to its max. Now, I know I shouldn't tell you that, since it is obvious. However, I feel it is always better to be safe than sorry, so here it is. Please, never touch the tip of the soldering iron when it is on, even if you think it is not that hot. Finally, always after each soldering session, please wash your hands thoroughly, especially if you use a lead-based soldering wire. The lead of such wires will not evaporate and you will not breathe it while you are soldering, but lead residues can remain on your fingertips and you can later ingest them. Soldering fumes do not contain lead, only rosin. There is not enough heat to make the lead evaporate. Just avoid breathing the fumes because they smell bad and you might be particularly sensitive and start coughing. Plus, rosin has a really an acid-like smell which you may want to avoid breathing. Let's now talk about another lab device that we want to keep safe, the multimeter. First, let me point out what is called the category rating or simply CAT rating. The CAT rating is usually indicated on the instrument itself. This one, for example, is certified for both the Category 2 and Category 3. This other one, instead, is only certified for Category 2. But what does that mean? Category levels let us know the maximum rating of an instrument according to this table. Cat 1 instruments are those only good to work on small electronic devices, or also high-voltage devices, but with very low power. Cat 2 instruments can be used like Cat 1 instruments, but additionally they can also be used to make measurements on appliances and portable tools working in AC. Cat 3 can be used like the previous two categories, and in addition they can handle higher voltages, like those present in three-phase distribution systems. And finally, Cat 4 can be used also for outdoor circuits, even when high energy is involved. Additionally, the category of an instrument also specifies the transient conditions under which an instrument should be used. That is because transient conditions allow for higher voltage measurements, but only for very short periods of times. This table provides for each category the max continuous voltage and the transient voltage associated to it, as well as the internal impedance of the energy source. For example, a Cat 2 instrument can be used to measure sources with an internal impedance of 12 ohms, and, depending on the max voltage value declared on the instrument specs, they should be able to handle transients up to what is specified in this table. So, for example, a Cat 2 instrument certified to work at up to 600 volts is supposed to be able to handle transients up to 4000 volts. Here are the typical probes used with a multimeter, which are usually held one per hand. At times, however, especially for measurements on small devices, one would hold both probes with a single hand, because the other one needs to do something else, like for example tuning a tree input or flipping a switch. In such a case, this is the proper way to hold both probes with a single hand. And if you have some problems with that, there are some tools that you can 3D print yourself or you can buy that holds the probes for you and make the job much easier. To avoid breaking the multimeter you are using, it is also important to set it appropriately for the measurements you need to perform. At least, you will have to set measurements unit that you need, and the device will take care automatically to select the most appropriate range. For totally manual instruments, however, you will have to set not only the measurements unit, but also the range. And be careful when doing so, multimeters can break. Always set a range higher than the max value you expect to measure. If you don't know what the max value could be, start with the highest settings, and then lower them one step at a time until you reach the lower possible range that is still higher than your max value under measurement. And finally, before using the probes, make sure they are fine. Check especially for any breakage in the wire's insulation. You don't want to get an electric shock inadvertently. Another tool category we need to talk about is the one of wire strippers and cutters. They seem to be simple tools to use, but an improper use of them may actually lead to frustrating mistakes, and can even damage components or cause injuries. There are different types of cutters and strippers for different tasks. Here are some examples. Using the wrong one for the task being performed can become a major hassle. The standard stripper has usually multiple holes of different sizes. To use it properly, you must match the hole size with a wire gauge. A self-adjusting stripper is less precise than the standard one, but it is better suited for bigger cables, like for example this coax cable. Using the most appropriate stripper for the job will prevent you from accidentally nicking or even cutting strands of wire, which can later weaken the connections and possibly cause a break during operations. Here are a few examples of wire cutters. A flash cutter like this is very useful to cut small wires, and it is perfect for cutting that extra length or component lead after they have been soldered to a board. A diagonal cutter is definitely most robust than a flush cutter, and it is most suited for thick wires or whenever a perfectly flush cut is not required. And of course, you may also have a combination tool. This wire stripper, in fact, can be also used as a wire cutter. Always try to match the size of the wire with the size of the stripper or the cutter. This will avoid nicking a solid wire or cutting a few thin strands of multi-strand wire. These events always weaken the wire, making it prone to breakage under use. Always cut away from yourself, and possibly wear safety glasses to prevent flying clippings to get into your eyes. Store these tools in such a way that the blades are protected from hitting other metallic tools that could damage them. And finally, never use an inappropriately small cutter to cut thick wires. The blade could get damaged. The last category of tools I would like to mention is the one of power supply units. Most of us have at least one of these units on the workbench. They come very useful when we need to power up a circuit we just made, and so we can test it. When doing so, always make sure to connect the cables using the correct polarity. Using colored cables make this much more easier. Be careful when using a variable power supply. Always double check that you have set the right voltage. Be aware that power supply units have fuses that can trip when the power you are using is above the limits of the unit. And some devices even give you the possibility of regulating the max current that can be erogated. In that case, be careful not to set it too low, or the voltage will decrease when the current increases. Also, do not set the max current to a value too high, or the power supply unit will not lower the voltage if the power absorbed by the circuit under test becomes too high. Finally, Pay attention to never short the outputs of the power supply. It might cause sparks, it might burn the insulation of the cables, and it might even cause a fire. And now just a few words of caution when dealing with circuits that are powered through a house outlet. Please, 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 working with AC mains voltage is extremely dangerous and should only be done either by experienced individuals or by their direct supervision. Don't do like myself, that when I was very young I tried to power my HO train directly from the power outlet. Yes, you got it right. I burned the locomotive motor and I blackened the wall around the outlet. I'm very lucky to be still here and be able to tell you this story. In general, when working with electricity and with electric or electronic devices, be always careful. Try to foresee what could happen before you do something. Read the manuals of the equipment you use and understand their capabilities and limitations. Always double-check the connections before powering up. If you can use lower voltages before providing the full power to the device under test, please do so. Start with a lower voltage and then increase it slowly so you will be able to notice any potential dangerous activity. Never be in a rush when working on your workbench. Rush is the mother of the worst mistakes. Don't let rush to overpower you. And finally, when in doubt, don't be ashamed to ask somebody else more expert than you. Nobody knows it all. Okay, I think this is enough talking about safety and procedures while running experiments in your own lab. Sorry if I annoyed you with all this talk, but I believe this was a necessary start of the new series on electronics basics. From now on, I will try my best not to bore you anymore. Instead, we will dive into the world of electronics, examining components, designing circuits together, experimenting with fun stuff, and more. I have a long list of subjects ready for you, and I'm sure you will enjoy all future episodes of this series. I'll see you soon in the next episode, and in the meantime, happy experiments! Oh, by the way, don't forget the fundraiser I mentioned before. We take clean water for granted in our society, but we should not forget that 1 person in 10, yes, you got it right, 1 person in 10 all over the world is not as lucky as we are. Let's help them with the teamwater project.